Hello everyone, I'm Dr. Navneet Kaur from Department of Computer Science and Engineering, Sagar Institute of Research and Technology College. Today I'll be taking lecture of subject Digital Systems. The topic which I'll discuss in this lecture is full adder and half adder. Now first thing, what is adder? An adder is a digital circuit that performs addition of the binary numbers. In modern computers, adders are located in the arithmetic logic unit, ALU. An adder circuit is one of the important digital circuits which are used in computers, calculators, digital processing units, etc. In many computers and processors, adders are generally used to calculate addresses, similar operations, and table indices in the ALU, and also in other parts of the processors. Now, adders are classified into two types, half adder and full adder. The half adder circuit, it generally operates on two inputs, A and B, and it generates two outputs, carry output and sum output. Whereas the full adder circuit has three inputs, A, B, and C, and it generates carry output and sum output. Now, first, we will see half adder in detail. The half adder, which I already discussed, accepts two binary digits on its inputs and it produces two binary digit outputs, a sum bit and a carry bit. This is a block diagram of a half adder in which we can see that the two input bits are given A and B and the two outputs are generated, sum and the carry output. Now, the truth table of the half adder is given in this slide. Here, A and B are two inputs and sum and carry out are the two outputs. Now, for two bits, there are four combinations 0, 0, 0, 1, 1, 0, and 1, 1. When we add 0, 0, we will get sum as 0 and carry output as 0. Now, for 0, 1, sum is 1, carry output is 0. Now, for 1, 0, sum is 1 and carry output is 0. And for 1 and 1, the sum is 0 and the carry output is 1. Now, if I'll calculate the expression for sum bit, then I'll see that the sum is getting 1 output when A is 0 and B is 1, that is A bar B. And also, when A is 1 and B is 0, that is AB bar. That means sum will be written as A bar B plus AB bar, which is given as A XOR B. Similarly, here carry output is 1 only for single combination where A is 1 and B is 1. So, carry output is given as A ANDed with B. Now, this is the logic diagram of the half adder circuit. Now, using the above equation A XOR B and C as A into B, now here we can draw the logic diagram using XOR gate and the OR gate. When A and B are XORed, it will generate the sum bit, whereas when they are ANDed, it will generate the carry output. Now, coming to the full adder circuit. Full adder circuits accept two inputs bits and an input carry, which will generate a sum output and the output carry. Here, the full adder circuit will add the input carry, which will be generated from the addition of the previous two bits. Now, this is the block diagram of the full adder circuit. Here we can see there are three inputs, A, B, and carry input. And the output is the sum output and the carry output. Now, this is the truth table of the full adder circuit. Now, since there are three inputs, so we will have total 8 combinations for 3 inputs, starting from 0, 0, 0 to 1, 1, 1. In between, we have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. Now, for these 3 8 input combinations, we will generate sum and carry output. Now say if all the 3 input bits are 0, naturally the sum will be 0 and the carry output will be 0. Now, if say A, B are 0 and carry input is 1, now we will have sum as 1 and the carry output as the 0. Now, suppose if we have A as 0, B and carry input as 1 and 1, then sum will be 0 and carry output will be 1. Now, if all the three input bits are 1, the sum will be 1 and the carry output will be 1. Now, if I generate expression for outputs bit sum and carry, the sum will be given as A XOR B XOR with C in. Whereas the carry output will be given as A ANDed with B plus C in ANDed with A XOR B. Now, using these expressions for sum and carry, we can generate the logic diagram of the full adder. Now, this is the logic diagram for the full adder. Now, these are the three inputs X, Y, and C in. Now, first we can see that X and Y are XORed here. So, I'll get X XOR Y. Now, for generating the sum bit, C in will be XORed with X XOR Y. So we will get X XOR Y XOR C in, which will be your sum bit. Here we can see sum is the XOR of the all three inputs. Now, for carry output, the expression is A XOR B is ANDed with C in and A is ANDed with B and both are ORed together. Here, A XOR X, A XOR B, or we can say the two inputs X or Y. Here, these are XORed and ANDed with C in. Similarly, X and Y are ANDed and the both outputs are here given to OR gate and this will generate your carry output. So this will be the whole logic circuit diagram of the full adder circuit. Now, if I'll see this diagram of the full adder, we can see that this block, it represents a half adder. Similarly, this block also represents a half adder and the carry output of both the half adders are given to the OR gate. That means the full adder circuit can be represented as the combination of the two half adders. So here we can see that the full adder can be represented as two half adders and the sum bit of first half adder is given to the input of the second half adder. And this is the sum of the whole full adder and the carry outputs of both the half adders are given to OR gate and will generate a carry output of the whole full adder. Now, coming to the advantages and the disadvantages of the half adder and full adder. First, we will see half adder. Half adder is flexible and easy because it is very easy to design the half adder. It involves the use of lesser number of logic circuits, therefore it is cheaper. The disadvantage is that it is restricted to addition of only two input bits and it fails to add a carry input from the previously added numbers. Now for full adder, it can add 3 bits. It includes one carry input and generates a carry output. And it can be cascaded to produce adders for a number of bit addition, which makes it suitable for multi-bit arithmetic. Now coming to disadvantage, it is complex and it needs more gates and hence the circuit will be complicated and expensive. Now, thank you. This is all for today's lecture.